You're doing fine, your calculus. All right, so we talked about this last time, and I was showing you the difference. We just picked 3 random basic elementary operations, and then we talked about the inverse of them. And we kind of compared it to the inverse of the inverse of solving a regular linear equation. So like if I divided an equation by 2, or if I had 1/2 x in a regular equation and I was trying to get x by itself, I would multiply by 2. And that would be the inverse operation. And so that's what we were talking about there. Now, I'm going to show you something in theory. You are not going to do this, so you can choose to write it if you want or choose not. And it's not on your little handout that I gave you. But here is something that you might, just something you need to see, I guess, about the elementary operations. And this is of theoretical interest only, and that's a 2. It looks Z-ish. There we go. 0, 2, 1, 1, 2. Okay, now, let's say that we were trying to write this matrix in row echelon form. Well, what we would do to write it in row echelon form is we would say, let's just interchange rows 1 and row 2, right? That's what we would do, and that's the real life what we would do, right? So we would say 1, -3, 6, 0, 2, 1, 3, 2, -1. So we would interchange rows 1 and 2, and that helps us go on our way to row echelon form. Now, the thing about elementary operations is this. Let's take an elementary operation, and let's do that interchange row 1 and row 2 with it. Now, what an elementary operation by definition means is one step away from the identity. Okay, so we're going to talk about this one in terms of I3. Okay, so there's our I3. If I perform this E1 operation, if I interchange rows 1 and 2 of this identity, I'm going to get 0, 1, 0, 1, 0, 0, 0, 0, 1. Okay, so technically, this is the E1 matrix. I performed that operation on it. It's an elementary matrix because it's one step away from the identity. You'll say, okay, so what's the point of this? All right, so let me show you what happens. And this is going to lead into our factory. And again, this is a theoretical interest only. I'm not going to ask you this on a test. Let's go back to this A matrix right here, our original matrix. And what I want to do with this A matrix is I want to multiply this matrix. It'll take me a minute, but I want to multiply it by E1. That doesn't take too long because I've got zeros and ones, right? But anyway, we're going to multiply these two matrices together. So I know that, of course, this is a 3 by 3 matrix, and this is also a 3 by 3 matrix. So I'm allowed to multiply them. And my result over here will also be a 3 by 3 matrix. You're saying, why am I doing this? I'm trying to show you how elementary matrices behave. But like I said, I won't ever give you this one. So we're going to go across the blue and down the pink. So when we multiply these, we get 0, 1, 0. Okay, let's go across. 0, -3, 0. 0, 6, 0. Okay, second row. 0, 0, 0. 2, 0, 0. 1, 0, 0. Bottom row. 0, 0, 3. 0, 0, 2. 0, 0, -1. Right, so what I got there by multiplying the blue and the pink matrices was the same thing that I got when I interchanged rows 1 and 2. And so what your book says is, let E be the elementary matrix obtained by performing an elementary row operation on I. Okay, so this is my elementary matrix. If that same operation is performed on an M by N matrix A, then the resulting matrix is EA. Okay, so in other words, switching 2 rows is going to be the same thing as multiplying that matrix by E1, which means that that's where it was switched by 2 rows, right? And so that is what they're trying to show you. And that's the premise that we're going to use, or this little fact here that we're going to use to factor these matrices down. Am I going to ask you that? No. So what happens, let's say that we were taking this A matrix right here, just still in theory land thinking about it. We were taking this A matrix right here. The first thing I would do is I would interchange rows 1 and 2, and that would give me this. And then the next thing I would do is say -3, row 1, plus row 3 gives me a new row 3, right? I would do that. And so this would be my first elementary matrix, and this would be my second elementary matrix, and I would keep on going. So basically what happens with this is I would take matrix A, and I would perform 1 operation, and I would perform 2 operations, and I would perform 3 operations, and however many it took. And once I performed those operations, it would work itself down into reduced row echelon form, which would be the identity. Now, I'm going to ask you in just a little bit to find A. So if I'm finding A, let's just put one more on here and just pretend for a second that it only took us 4 steps, which it would take us more than that. But if it took us 4 steps. Once I say that this would take me these 4 steps to find A, I'm going to undo it. So I would say E4 inverse, and these would cross out. And I would say E3 inverse, and these would cross out. It's like dividing, right? E2 inverse, and these would cross out. E1 inverse, and these would cross out. So A would actually be equal to E1 inverse, E2 inverse, E3 inverse, E4 inverse times I, which is just like timesing 1, right? You could put the I there, but you don't have to. That is what we're about to be doing. And so when I ask you to factor matrices, you're going to have a matrix. I'm not going to make you do 3 by 3 because that would take us till now to a forever. So we're not going to make you do 3 by 3, but you're going to take that A and you're going to break it down this way. And that is how it's going to look. Now we talked last time about the inverse operation, so we talked about that. And I gave you a little sheet, but I can't even remember what your sheet looked like, so let's look at it. Did that? Oh, back page. See if I'm ready. Am I ready? I think I'm ready. Now you have one on your sheet, and I actually don't have that one worked out. So hold tight on that one. Hold this because we're going to do this one second. But find a piece of paper and let's work this one. Bless you. Okay, and the reason I want to go ahead and start with this one is I know the answer. So I want to show you the answer first where you know where we're even going with this, because it's hard to know what to do when you don't know where we're going. So once we work this out, your answer for this one is going to be A. This is your A. A equals 1051, 100, negative 8, 1301. Okay, so that's what your answer is going to look like. That's factored into a group of elementary matrices, and all these blue matrices that you see are one step away from the identity. Okay, and so that's what it means by elementary matrices. If we were to take the 3 blue matrices and multiply them out, and you know, because we know how to multiply now, if we were to take them and multiply them out, we're going to get that original. Now, on your sheet, and you'll be able to use your sheet in just a little bit, but on your sheet, I put 3 little columns. And that's how I think of them. Here's what we're going to do. We're going to start with this matrix A, and we're going to use Gauss-Jordan elimination, and we're going to work our way down with matrix A until we get this. Okay? So how you want to handle it is up to you. Some of my students just go straight here where it says operation, and they say, okay, I'm going to say -5 row 1 plus row 2 gives me a new row 2. And then I'm going to get this 1 in this position, and then I'm going to get this 3 in this position, and they go ahead and they do that whole first column at one time. And that's fine. You can do that. But some people say, okay, I'm going to take care of just step 1 all the way across. Operation, elementary, inverse. Then I'll do step 2. It's up to you. However you want to handle it, as long as you get the answer, it works for me. Also, we were talking about grading in another class today. There are 4 of us in here today. There could possibly be 4 different answers to it. So I do have to grade these all at one time. And you'll say, well, how can there be 4 different answers? Well, let's think of it this way. Let's say I had the number 24, just a regular number, and I was like, okay, let's find the factors of 24. Will might pick this, and Joseph might pick this, and I might pick this, and Jenna might pick this, right? There's different factors that still multiply to give you 24, and that's going to be the same over here as well. So, there's more than one answer. What I'm going to do first to get this matrix in the right form is, first of all, I have to make sure I have a 1 there, and I do. Yay. So if I did not have a 1 in that position, my very first step would be to get a 1 in that position, and I have it. Okay, so my next part is to get rid of the 5. So I'm going to say, this is one time that I encourage you to write out this little step. It's going to help you. -5 row 1 plus row 2 is going to give me a new row 2. And that's my operation. The first operation that I'm going to do is say -5 row 1 plus row 2 gives me a new row 2.
So the first thing that goes under operation.
I hadn't done that yet. Hold tight. So let me get this orange part done, and then you'll see. So I'm going to take -5 and run through. So that's -5, -15. 5, 7. I'm going to add them up, and I get 0, -8. So this first operation that I'm going to get is going to give me this. Now, maybe operation might not be my best thing. The operation is here. Let's say matrix work. That might be better served. Because I'm over here on this side, I want to simplify down or reduce that matrix down into a reduced row echelon form. So let's call that matrix work instead. All right, and that's how we start. Are there any questions with that so far? Now, I'm just going to go with it all the way across with it. So let's go over here and let's find our inverse operation. Now, we talked about this at the end of class last time. The inverse of -5 row 1 plus row 2 is going to be +5 row 1 plus row 2. Okay? Because thinking about it, like if you were kind of comparing it to a linear equation way back when, the opposite of -5 is add 5. And so that's how you're thinking of this. This is like subtracting 5 here, and this is adding 5. Now, at this little point right here, here's my identity matrix. I'm going to go ahead and perform this operation right here on that identity. So it would be 5 times row 1 plus row 2 gives me a new row 2. So row 1 stays the same, and that's my new row 1. 2, my new row 2. 5 times row 1 plus row 2 gives me a new row 2. Any questions with that part? All right, so let's go back over here. My next step, let's do this one green. My next step is to get rid of the 8. So to get rid of the 8, I'm going to say negative 1/8 row 2 gives me a new row 2. And that's my second operation. That's how it looks. All right, E2 inverse. Now, this is basically you're thinking about this as dividing by negative 8. And the inverse of dividing by negative 8 is multiplying by negative 8. And you'll say, well, what about the sign? The sign only changes when you're adding or subtracting, but when you're multiplying, the reciprocal, the sign doesn't change. So if I'm taking a negative 1/8, the reciprocal of that would be negative 8. Now I'm going to erase this big orange. Oh, it's already erased. There we go. Can't see it anyway. Now, here's the thing about it. Here's the hard part to remember. This is a brand new elementary matrix. So you're not going to build off the orange one because remember the definition of elementary is it's one step away from the identity. So we have to think, okay, the identity of this one looks like this. That's what so I've got to work off of that. I'm not working off of the orange. The orange was last step. It's a long time ago. So we're going to work off of this one. Okay? So if I take this, I'm not touching row 1, but I'm going to say negative 8 row 2. And that's what it would look like. And this would be your E2 inverse. Now, we have to get rid of the 3. So to get rid of the 3, we're going to say negative 3 row 2 plus row 1 gives me a new row 1. Whoops. Got a little carried away. Negative 3 row 1, 2. Negative 3 row 2 plus row 1 gives me a new row 1. Okay, so here it is. We're going to say 0, negative 3, 1, 3, 1, 0. Yay! Okay, that's where we were going. Excellent. Okay, so let's talk about the first column for a second. The first column is just where I do my matrix work. You may not have to do that part. So that's kind of like for me, that's my scratch work column, and that's what I do there. Now, it helps me if I write out the operations, and you know, you've known me for a couple of months now. I always write out my operations every time anyway. So that's my second column, and then the third column would be the inverse. Are there any questions with the pink step so far? All right, so the inverse here, okay, we start anew. Okay, so I'm going to be building off of the identity, right? Not building off the green, but building off the identity. My current pink operation is negative 3 row 2 plus row 1. And so my inverse operation is going to be positive 3 row 2 plus row 1. Now, the other thing that you're going to notice is that your rows aren't going to change. Like if I'm not going to switch, when I'm doing these inverse operations, I'm just switching the coefficient. I'm just inverting the coefficient, whether it's adding, changing to subtracting, or multiplying, changing to dividing. I'm not doing anything to the row placement. Okay? So if I look at this one, 3 times row 2, add it to row 1, and that's my new row 1. That's what it looks like. Okay, and that's you've done all the work, but you don't have an answer. And so we have to tie it all up. And that is what's left. So let's look at it. Here's what we did. We took matrix A, let's make it blue because it was blue to begin with. We took matrix A and we did the pink step. That's not pink, that's orange. The orange step. And then we did the green step. And then we did the pink step. And when we did that, that gave us I. So we did the first elementary operation, negative 5 row 1 plus row 2. And then we did the second elementary operation, negative 1/8 row 2. And then we did the third. And that's what we did. When I ask you to find A, that means I need to solve this equation for A. So the first thing I have to do is I have to get rid of this guy. If I do it on the left of the left, you remember my placement. If I do it on the left of the left, I do this one on the left. Okay? So then I need E2 inverse. That's at the left again. This is at the left of the left, or left of the right, I guess. Okay, so then I do E1 inverse. That one's next. So what I get from that is that A equals E1 inverse, E2 inverse, E3 inverse times I, and I is just like multiplying by 1, so you can either put it or not, it doesn't matter. And that's going to be my answer. So if we look back over there, the placement is really important. E1 is 0, that's 1, 1, 0, 5, 1. E2 is 1, 0, 0, negative 8. And E3 is 1, 3, 0, 1. And that's your answer. Okay, for me, I will only give you 2 by 2. So you wouldn't, the most elementary matrices that you would have as a factor group would be 4. So I'm not going to give you one that's 9, not even for practice, for fun. I won't do that to you. So that's how they're going to look. Now I put every possible step that I could in there. You don't have to put all those steps in there. Can you? Absolutely you can. But if you can skip some steps, that's fine too. And that is how it would look. Do you have any questions for this? All right, so go ahead.
Could we swap column 1 and 2 if it just made more sense to us?
Absolutely.
Because we always wrote down in the middle column and then the first column.
Sure. Absolutely. And like I said, that's just how I think about it. So that's my column. That's what works best for my brain. So you can set it up however you wish. The only way that my students usually miss it is here at the end. They'll even get their E1, E2, E3 inverses all right, but they'll put them in a bad order. So be really, really detail oriented at the bottom. And some people know, hey, I'm just going to start at the top and write them in order, like that work. My brain doesn't see it that way, but you could, if you've got some shortcuts for it, you take them. Just be really careful at this step that you put them in the proper order. Okay, so now you have one on your sheet that says write as a product of elementary matrices, and it's 1, 3, negative 2, 4. So I want you to try it. I'm going to work at 2. I'm going to give you a head start. It's the one on your sheet. So you get a head start and I'll catch up. Sure worksheet. Okay, so here's another take on that. Of course, I had a 1 in my top position, which is great. So that means that was one less step that I had to do. So you always want to start with a 1. And I'm just stopping there for just a second because it may be that you have one on your homework or on your test that or your worksheet where it's not a 1. So just be cautious if it's not a 1 there. That's where you need to start. In both of my examples, it's been a 1 there. So I I reduced this down to reduced row echelon form, and I did 3 steps, E1, E2, E3. And so here's another take on it if you wanted to work it this way. So I did take A, we'll call this A, and I worked it out to get the identity. Boom, done. Now I can come over here to my inverse side. Let's make it red for the inverse. I can come over here to my inverse side and work those. Now that's in my way, so I'm going to move it. Okay, now I'm ready. E1 inverse. Okay, so the opposite of 2 would be negative 2. Okay, so if I did this operation on the identity, I'm going to get 2, 0, 0, 1. And so that's going to give me 2, 1, 1, 0. Now, let's try that again. Negative 2, row 1, plus row 2 gives me a new row 2. Okay, I think I like it. So E2 inverse, the inverse of 1/10 would be 10. Okay, and so I'm going back to the identity, not the red one, and I'm multiplying row 2 by 10. E3, negative 3 row 2 would be positive 3 row 2 plus row 1 gives me a new row 1. Throw me an identity up there where I can see it better. So 3 times row 2 plus row 1 gives me a new row 1. That's how it looks. Now, that's how I think of it. So I took A and I did 1 operation, 2 operations, 3 operations to get the identity. So to get rid of it, I'm going to say this operation, then this operation, then this operation equals A. So A would equal 1, 0, negative 2, 1. 1, 0, 0, 10, 1, 3, 0, 1. Okay, so that is how I work it. I'm going to cheat for a second because I did find it. Okay, so I cheated and looked, and that looks right what's on my paper. And you might have gotten something a little different, and that may also be correct. But let's say that this was a test, because I worked it right here like I was just working it myself, not in front of you guys. So I would work it out just like I did there, and then when I get to the end, I'm going to check mine. And so the way that I'm going to check it, and so it's also the way I check some of yours if it's not the one I have, is I multiply it out. So once I get here, I might check it just for your own benefit. So I'm going to you can only do 2 matrices at a time, right? So I'm going to multiply these. This gives me 1, 0, 0, 0, negative 2, 0, 0, 10. Okay? So I'm going to multiply that times the other matrix that's left over. So if I multiply these, I get 1, 0, 3, 0, negative 2, 0, and negative 6 plus 10 would be 4. And that's what I started with. So that lets me know that I worked it correctly because I got what I was looking for at the end. And I know it's a lot of work there, but this is my answer. Now, you might have worked yours differently. You might have done, gotten rid of something else in front of a 3 instead of a 10 first. Then that's fine too. You might have a different answer in the box, but if you multiply it out and you get that A matrix that you started with, it is going to be correct. All right. Does anybody, I can make it bigger or smaller where we can all see it. Does anybody have any questions with it? Okay. On the bottom of that sheet, we talked about it just a little bit. Let's go ahead and finish that note sheet that you have. It's a theorem, and I ask you that theorem a lot on various tests. We talked about it a little bit last time. I kind of just left you hanging with it. So theorem 2.15 says these are equivalent statements. If any one of these is true, then they're all true. And first of all, it's prefaced at the top by saying this is an n by n matrix, so it has to be square. So if you have a square matrix that is invertible, then that means that AX equals B has a unique solution. Okay, so that means that if you had a regular traditional matrix equation or system of equations, it's going to have one single answer. If you had a system of equations that was homogeneous, meaning it equals 0, then that only has one unique solution. And we know if it only can have one unique solution, that one has to be the trivial. A is row equivalent to IN. Here's what that means. Here's A right up here. Row equivalent means that I can get to the identity by a series of elementary operations. So I went from A to I by saying E1, E2, E3. And so that is what row equivalent means. I can get from point A to point I by a series of row operations. A can be written as a product of elementary matrices. Okay, so that's what this is as well. I can factor it down into elementary matrices. Another thing that you can add to that I would be glad to give you credit for, it says A is invertible. And so we'll add this in chapter 3. You can go ahead and add it now if you'd like. Number 6, if you want to put number 6 on the list, is determinant is not 0. If the determinant is 0, it does not have an inverse. It's singular. You can also say that on there. If we're putting things on there, this is non-singular. So, and what that, it's not a thing of invertible means these things. It's just equivalent statements. If your determinant is not 0, then you have an inverse. If your determinant is not 0, then you have a unique solution and that type of thing. And so that's one of the things that I usually ask you. I don't ask you all 7 of them, but I'll say, hey, if this has an inverse, tell me something I know about it. And I like that kind of question. All right. Surprising to me, as I was flipping through my notebook, because I haven't been going forward, I've just been doing day to day, you are done. You're done with chapter 2. D-O-N-E. Okay, so that means that we're ready for a test. So what we'll probably do, and I'll talk to you guys about it because you may have a lot of stuff next week. But right now, my plan would be on Monday we review. And on Wednesday we test. And that would be Wednesday, I believe that's October the 1st. Now that plan works good for me, but that plan may not work good for you. So if that plan doesn't work good for you, my other option would be do new stuff, but it's just determinant. It's not new stuff that's going to affect you in any way. It's not going to mess you up. But we could do new stuff, then we could review, and then you could have your test on Monday, that's going to be the 8th, 7th, 6th. Okay, if you need more time, we can also do that. So think of your other classes that you're taking, and we can work it. I don't want to do past the 6th because I have to grade it, and that's when my midterm grades are due. So your midterm grade for me is just going to be your first 2 tests. I'll probably not that you need it dropped because everybody did fine, but I'll probably go ahead and drop the first test, your lowest test grade too. And so basically it's just your first 2 tests averaged together. And so that is our plan. And then we'll have fall break. Yeah, you guys get 1 day of fall break, I guess. So that is the plan. If you've got some questions for me, stick around. Otherwise, be thinking about your test and thinking about questions. Everybody should have a review sheet that you can start peeping over and seeing what you